Galaxies are vast collections of stars, gas, dust, and planets. Imagine billions or even trillions of stars all held together by gravity. That's a galaxy. Our sun is just one star in a giant spiral galaxy called the Milky Way. Think of galaxies as islands scattered across the universe. Just like islands on Earth, galaxies come in different shapes and sizes. Some are small and faint, while others are huge and bright. These islands of stars are where stars are born, live, and eventually die. By studying galaxies, we learn about the universe itself, its history, and its future. There are three main types of galaxies: spiral, elliptical, and irregular. Spiral galaxies, like our Milky Way, have arms of stars, gas, and dust that spiral out from a central bulge. They look like giant pinwheels. Elliptical galaxies are more rounded, like a football or an egg. They contain mostly older stars and less gas and dust than spiral galaxies. Irregular galaxies don't have a regular shape. They often look messy and chaotic, but that's part of what makes them so interesting. Each type of galaxy tells us something different about how stars form and how galaxies evolve over time. Believe it or not, galaxies can collide. Space is so vast that you might think galaxies would rarely bump into each other. However, gravity is a powerful force. It can pull galaxies together over billions of years. When galaxies collide, they don't crash like cars. Instead, they pass through each other. Their gravity disrupts the stars and gas, creating spectacular displays of star formation and changing their shapes. Sometimes, galaxies merge completely, forming a single, larger galaxy. These collisions play a big role in how galaxies grow and change over time. Some galaxies are particularly famous, like the Whirlpool Galaxy. This galaxy, also known as M51, is located about 23 million light-years away in the constellation Canes Venatici. Its striking appearance, with well-defined spiral arms and a bright core, makes it a favorite among both amateur and professional astronomers. The Whirlpool Galaxy is actually interacting with a smaller galaxy, NGC 5195, which is thought to be responsible for the Whirlpool's grand design. This interaction triggers waves of star formation, lighting up the galaxy in spectacular fashion. This stunning spiral galaxy, with its prominent arms and central core, is a favorite target for astronomers. Observing the Whirlpool Galaxy provides valuable insights into the dynamics of galaxy interactions and the processes that drive star formation. By studying the Whirlpool, scientists can learn more about the life cycles of stars and the complex gravitational dances that shape galaxies over billions of years. It helps us understand how stars form and how galaxies evolve. The Whirlpool Galaxy, with its active star-forming regions, serves as a natural laboratory for studying these processes. By examining the different stages of star formation within the galaxy, astronomers can piece together the history of stellar evolution and gain a deeper understanding of the forces at play in the universe. But there are also incredibly distant galaxies like GNZ 11. This galaxy, located in the constellation Ursa Major, is one of the most distant and oldest galaxies ever observed. It lies about 13.4 billion light-years away, meaning we see it as it was just a few 100 million years after the Big Bang. The light from GNZ 11 has traveled across the vast expanse of the universe, giving us a glimpse into the early stages of galaxy formation. This galaxy is so far away that we see it as it was just a few 100 million years after the Big Bang. Observing such ancient galaxies allows astronomers to study the conditions of the early universe and understand how the first galaxies formed and evolved. By analyzing the light from GNZ 11, scientists can learn about the composition, structure, and behavior of the universe in its infancy. Studying such distant galaxies allows us to look back in time and understand the early universe. These observations provide crucial data for testing theories about the formation and evolution of galaxies, the nature of dark matter and dark energy, and the overall structure of the cosmos. By peering into the distant past, astronomers can piece together the story of our universe from its earliest moments to the present day. All galaxies are connected by a vast network of gas and dark matter called the cosmic web. This intricate structure, composed of filaments and voids, spans the entire universe and plays a crucial role in the formation and distribution of galaxies. The cosmic web acts as a framework, guiding the movement of galaxies and influencing their interactions. This web acts like a giant cosmic scaffolding, influencing how galaxies form and cluster together. The gravitational pull of dark matter within the web shapes the large-scale structure of the universe, creating clusters, superclusters, and vast empty regions known as voids. By studying the cosmic web, astronomers can gain insights into the distribution of dark matter, the behavior of galaxies, and the overall architecture of the cosmos. Galaxies are not static objects. They are constantly evolving and changing over time. They start as giant clouds of gas and dust. Gravity pulls the gas and dust together, causing it to collapse and heat up. Eventually, the core of this collapsing cloud becomes hot and dense enough to ignite nuclear fusion, giving birth to stars. Over billions of years, galaxies form more and more stars, eventually becoming the majestic structures we see today. Understanding the life cycle of galaxies helps us piece together the history of the universe and predict its future. Section 6, the Milky Way, our galactic home. The Milky Way galaxy, a vast and magnificent structure, is our cosmic neighborhood. It is a barred spiral galaxy, one of the most common types in the universe, and it is home to our solar system. Our solar system is located in the Milky Way galaxy, a barred spiral galaxy with hundreds of billions of stars. These stars, along with vast clouds of gas and dust, form the intricate and beautiful structure of our galaxy. The Milky Way spans about 100,000 light-years in diameter, making it a colossal entity in the cosmos. From our vantage point on Earth, we see the Milky Way as a band of light stretching across the night sky. This band is actually the combined light of millions of stars that are too faint to be seen individually. On a clear night, away from city lights, the Milky Way reveals its splendor, reminding us of our place in the universe. The Milky Way is a dynamic place, with stars constantly being born, living out their lives, and eventually dying. Stellar nurseries, regions where new stars are formed, are scattered throughout the galaxy. These nurseries are often shrouded in clouds of gas and dust, which eventually coalesce to form new stars. As stars age, they go through various stages, from red giants to white dwarfs, and some end their lives in spectacular supernova explosions. It even has a supermassive black hole at its center, a region of intense gravity that warps space and time. This black hole, known as Sagittarius A*, has a mass equivalent to about 4 million suns. The area around it is a hub of high-energy activity, with stars and gas swirling at incredible speeds. Studying the Milky Way gives us a close-up look at the processes that shape galaxies and the universe as a whole. Astronomers use powerful telescopes and advanced technology to observe and understand the complex interactions within our galaxy. By studying the Milky Way, we gain insights into the life cycles of stars, the formation of planetary systems, and the fundamental forces that govern the cosmos. Our galactic home is not just a collection of stars and planets, it is a dynamic and ever-changing environment that continues to captivate and inspire us. Section 7. Galaxies far, far away. Thanks to powerful telescopes like Hubble and the James Webb Space Telescope, we can observe galaxies billions of light-years away. This means we see them as they were billions of years ago, offering a glimpse into the early universe. These distant galaxies are fainter and smaller than nearby ones, but they provide valuable clues about how galaxies form and evolve. By studying them, we can learn about the conditions in the early universe and how galaxies have changed over time. The farther we look into space, the further back in time we see, allowing us to piece together the history of the universe. Section 8. Unlocking the secrets of the universe. Galaxies are like giant laboratories for studying the laws of physics on a grand scale. These massive collections of stars, gas, and dark matter are not just beautiful to look at, they are also key to understanding the fundamental principles that govern our universe. Each galaxy, with its unique structure and behavior, offers a wealth of information that can help us unlock the secrets of the cosmos. By observing how galaxies interact, evolve, and are influenced by dark matter and dark energy, we can test our understanding of gravity, cosmology, and the fundamental nature of the universe. The collisions between galaxies, for instance, provide a natural laboratory for studying the effects of gravitational forces on a massive scale. These cosmic events can trigger the formation of new stars and even alter the shape and structure of the galaxies involved. There is still much we don't know about galaxies, but each new discovery brings us closer to unraveling the mysteries of the cosmos. Scientists around the world are constantly developing new technologies and methods to observe and analyze these distant objects. From ground-based observatories to space telescopes, each tool provides a different perspective and helps us piece together the complex puzzle of our universe. As we continue to explore the universe with ever more powerful telescopes, we can expect to make even more groundbreaking discoveries about these fascinating objects. The next generation of telescopes, such as the James Webb Space Telescope, promises to reveal details about galaxies that were previously beyond our reach. These advancements will allow us to look further back in time to the very formation of the first galaxies and understand how they have evolved over billions of years. Through the study of galaxies, we gain a deeper understanding of our place in the universe and the vastness of the cosmos. Each discovery not only answers some of our questions but also raises new ones, driving our curiosity and pushing the boundaries of our knowledge. The journey to unlock the secrets of the universe is ongoing, and with each step, we come closer to comprehending the true nature of the cosmos and our place within it. Section 9. Keep looking up. The next time you look up at the night sky, remember that you are looking at a universe teeming with galaxies. Each point of light represents a vast collection of stars, planets, and mysteries waiting to be explored. Never stop asking questions about the universe and the incredible objects it contains. Keep exploring, keep learning, and keep looking up. The universe is a vast and wondrous place, and there is still so much more to discover.